Hello everyone, and welcome back to Introduction to Mining Engineering. I'm Dr. Sekhar Bhattacharyya, instructor, and today we are going to explore one of the most fascinating and technically demanding topic in our field, which is underground mining. Why do we go underground? Underground mining is often the best choice when the deposit is too deep to remove economically using surface methods, when stripping ratios become too high, or when the surface area above the ore is occupied by infrastructure, urban areas, or environmentally sensitive land. Sometimes the geometry of the ore body itself makes the underground mining the most efficient choice. How do we reach the ore body? Before we can start extracting, we need a way to get in. There are three common approaches. One is the shaft, which is a vertical or near vertical entry. It's used when the ore lies deep underground. Shafts can carry miners, equipment, and sometimes ore. Then we have the declines or ramps, which are the sloping entries that allow vehicles to drive in and out, usually at gradients of 1 to 7 or 1 to 8. Then we have the adits, which are horizontal or near horizontal entries, which are driven into a hillside. They're often used when the deposit is exposed at the surface on a slope. In coal mining, you might see a two-compartment slope, one for a belt conveyor carrying the coal out, and another which is for the miner and supply vehicles. Once you are underground, the mine is laid out in a network of openings with specific purposes. The drifts and crosscuts and raises, they form the transportation and ventilation arteries for the mine. Pillars are blocks of ore left in place to support the roof, and stopes are the voids created when ore is removed. Levels are horizontal slices of the mine, each connected by raises or ramps. The main underground mining methods fall into three different broad categories. They are based on how the ore or surrounding rocks are supported. Number one is the unsupported methods. These rely on the natural strength of the rock with minimal added support. Some of the examples include room and pillar, which is very common in coal, salt, and porous mining. Rooms are mined leaving pillars of ore to support the roof naturally. Pillars may be partially removed in the final retreat stage. Then we have the open stoping and the shrinkage stoping. These are used for steep, strong ore bodies, which allowing gravity to move the broken ore. Talking about the supported methods, where artificial supports such as timber, rock bolts, or backfills are added. These are some of the common methods, like cut and fill is a good example. These are ideal for irregular ore bodies. Then we have a very large method which is called the caving methods. These are controlled collapse to break the ore. Longwall mining in coal is highly mechanized. It produces very high outputs, and block caving and sublevel caving, those are used in large low-grade ore bodies like copper, diamond, or similar materials. What are the most common methods in US? In the United States in 2023, we have 464 underground mines, out of which 234 are coal mines, and roughly the same number, of course, are the non-coal mines. Room and pillar is by far the most common methods. In non-coal mines, you'll find a mix of room and pillar, cut and fill, and open stoping, with a few using shrinkage or caving methods. Keeping it safe in the underground comes next. The underground environment can be dangerous, so ground control is critical. We use rock bolts, mesh, shotcrete, steel set. These are to stabilize. based on rock quality and stress conditions, and of course the excavation sizes. Ventilation is another key aspect, removing dust, diluting the toxic gases, and providing fresh air. We used main fans, auxiliary fans, and regulators, often controlled with smart systems that adjust airflow where it's needed most. Modern technology underground is changing very rapidly, and we now have autonomous loaders and trucks, remote controlled drilling rigs, real-time monitoring for gases, rock movement, and equipment health. Digital twin models let us simulate operations before we commit to a design, which can be very expensive, of course. These advances improve safety, productivity, and efficiency. When thinking beyond the ore, underground mining reduces surface disturbance compared to the open pits, but it can still cause issues like subsidence or groundwater impacts or similar. Responsible mining means monitoring these effects, engaging with local communities, and planning for the mine's closure from day one. Post-mining land use might involve stabilizing the ground, sealing openings, and sometimes repurposing infrastructure for other uses. Wrapping up, underground mining is a blend of engineering skill, careful planning, constant attention to safety. It allows us to reach valuable resources deep underground while minimizing our footprint at the surface. As future mining engineer, your role will be to choose the right method, design it safely, and operate it responsibly, making sure we meet society's needs while protecting workers and the environment. That's all for today. I'll see you sometime again. Till that time, keep learning and stay safe.